Dear children, welcome to the fourth module of our chapter, Force and Laws of Motion. Have you learned the previous topics? We already learned about Newton's first and second laws of motion. Today, we are going to discuss some of the applications of Newton's second law of motion. Do you remember what is Newton's second law of motion? The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. From this, we can see that the force is inversely proportional to the time in which the change in momentum takes place. So, our applications are explained based on this concept. So, let's start our topic.
Now we can discuss some applications of Newton's second law of motion, which is very familiar to you. You may have seen a cricketer lowers his hands to take a catch safely in the game of cricket. As the cricketer lowers his hands, he is allowing the ball to be in air for a longer time. Thus the change of momentum takes place in a longer time. By second law, force is inversely proportional to the time in which the change in momentum takes place. So the force exerted by the ball on his hand becomes less and he will be saved from injury. Let's discuss another example. You may have seen a karate player breaks a slab of ice with a single blow. This is also another application of Newton's second law of motion. A karate player hits the ice block swiftly. Thus, the change in momentum takes place in a shorter time. By second law, force is inversely proportional to the time in which the change in momentum is taking place. So, the force exerted by the karate player on a block of ice is huge enough to break it. You may have seen sponge bed is provided for the athletes taking part in high jump. This is also an example of Newton's second law of motion. When the athlete jumps onto the sponge bed, he or she comes to rest in a longer time. Thus, the change in momentum takes place in a longer time. By second law, force is inversely proportional to the time in which the change in momentum is taking place. So, the athlete will have a safe landing after the high jump.
Taken, beautiful catch.
Dragged and caught. Brilliant catch.
There's an old saying called catches win matches. It's been proven over the years, and let's see what makes a good catch. Mainly, there are two types of catches: flat catches and high catches. In both cases, you are catching a ball which is moving in different speeds at different angles. Let's consider a high catch, which is airborne vertically upwards, and say it goes high up in air. As it comes down, a fielder goes under the ball to catch it. Right, now assume that there are two types of catchers. One who stretches his rigid hand suddenly right onto the ball. The other fielder takes a soft catch, dragging the ball down, allowing it to stop smoothly. Which fielder do you think has a chance of holding on to the ball? Well, it's quite easy to answer: the second fielder. Why is that? We can easily find this from science. The great physicist Isaac Newton, in his second law of motion, states that the unbalanced force applied on an object is directly proportional to the rate of change of momentum along the direction of the force applied. When this is shown in an equation, force is equal to the change in momentum divided by time, which we call as rate of change of momentum. Here, m is the mass of the ball, V is the speed of the ball just before it hits on hands. U is the final speed of the ball when it stops in hands, which is 0. And T is the time duration that the ball keeps in contact with the hands. In both these instances, mass of the ball m is same, speed of the ball before we catch v is same, final speed when it stops in hands u is 0. So now we can say force F is inversely proportional to the time. This means that the force felt on hands depends on the time that the ball keeps in contact with the hands. Longer the time, lesser the force felt on hands. Therefore, to secure a catch safely with a less pain and good chance of holding on to the ball, it is required to drag the ball down, or you can bend from knees when the catch is taken so that the ball would exert a small force on hands as the contact time is increased.